Today, I want you to start thinking about events and thinking with events. So let's set up our little hypothetical situation with a game. Shooterman 64. Super generic FPS. We have been tasked with building the back-end services for this game. Because this game has multiplayer, of course, MMR matchmaking, of course, leaderboards, of course, and KPIs, of course. So, when a match ends, there's a couple things that we're going to want to do. We're going to want to update the player's MMR. We're going to want to update the ranking, so we have our updated leaderboards that you can view. And then we're going to want to update the KPIs. Seems reasonable.
What is MMR?
Oh, sorry. MMR is matchmaking rating. So if you have a high MMR, you're up against high-skilled players. And if you have a low MMR, like me, you're up against other not good people.
Like Chris.
Yeah. So we're hip, we're cool. Let's use microservices. So we have a game server that handles what you might imagine a game server handles, runs the game. And at the end of each game, we're going to send out a message to our MMR service, our skill rating service, our ranking for leaderboards, and to our KPI services. Seems reasonable. But there's a couple of problems with this. This is a dependency graph. This is like literally the definition of a dependency graph. The game server now depends on your MMR service, your ranking service, and your KPI service. And there's some nasty things that come along with that. The responsibility for the game server now includes needing to know how to talk to each of these services. And there's some really nasty problems when other things go wrong. What happens when your MMR service just goes down? It's down for 2 minutes. A node went down in your cloud somewhere, everything's on fire, they finally fix it. What do you do? Your ranking service has a bug. 3 weeks after your last deploy, you realize that your leaderboards are slightly scrambled in certain ways. After a very angry user told you about this. That never happened on Dofus, I'm sure, apparently. What happens when your KPIs are down for maintenance? Oh no, we need a bigger hard drive. We have to take this down for 20 minutes to swap out and get ourselves some more space. All that time, either you bring down the game server and no one can play your game, or data is lost. And there's other issues too. Right? You have strong coupling between the game server and all your services. Right? The benefit of microservices is supposed to be, oh, everything's just responsible for its own little thing. Well, not really in this case. Because an update to a service API means suddenly you have to update the game server as well. I change how my skill ratings are being called. I have to bring down the entire service in order to do updates for my game server to be able to call this new endpoint. That sucks. And adding or removing services is a whole affair in itself. If I add a new service, if I add a profile service, a user profile service, where I want to say, this user has played on this map, here's like your most popular maps for this month, here's your most win rates, most played characters, and so on. If the game server has to call out to that, I have to bring down the game servers in order to apply these changes. And that creates an exponential web of calls. There's also a more subtle thing. Updates have to work. And that sounds like it should be obvious, but I think it's something we take a little bit for granted. So updates have to work. What I mean by that is that when you push to production, you better hope that works. Because if it doesn't, everything's on fire. Good luck, have fun, you're going to be up until 2 in the morning. A sneaky bug may make it even worse. Our leaderboard bug, 2 weeks of bad data slowly tentacling its way into our database and swapping around certain people here and there. Do we even have a backup from over 2 weeks ago? Does it help? What do we do? So, let's talk about something completely different. Let's talk about event logs. To talk about event logs, we have to talk about events. So what is an event? Let's be very, very strict about this. An event is something interesting happened. For example, a match started. A player joined that match. A match ended. You could get more granular. You could say a player used an ability. A player sent a text message. A player made a friend. A player created a group. And so on. And we have some data about that interesting thing that happened. So when a match started, what map did they pick? Who was in their groups? what characters are being played. An event log is just an ordered list of events that happened. Match started, match ended, so on. But we're going to follow a few strict rules here that may sound a little bit nasty at first, but I promise you they're worth it. We have an example event log. Game started. We have some data about that event. A map was chosen. Players waited 2 minutes in a lobby. We can start throwing some KPI stuff in there because why not? The game finished. Player F won by 20 points. The game lasted 8 minutes. Map ABC was chosen. We can duplicate a little bit of data here. That's okay. But we have some attributes that are very important. It is an append-only list. You cannot rewrite history. An event happened, deal with it. That's basically the motto of the event log. You can have multiple readers. An event is not consumed by any service. When you look at an event log, you can start from the beginning. 30 other services could also be starting from the beginning and reading over those same events that you are. And finally, you can read from any point. You can say, give me starting from event number 3. And it will give you starting from event number 3, as far back as you want. And we have a couple options if we actually want to get into the technical side of that. Just throw this in a text file. Don't throw this in a text file. But theoretically, you could. This is a concept, not a technology. You could put it in Mongo. Mongo is great for storing a ton of just blobs of data, which is exactly what we're dealing with here. You can get a little more specific. You can use Redis streams, which allow you to create these event streams that you can then read for multiple readers, starting from any given point, and that scales out pretty nicely. You use Amazon Kinesis in S3 if you want to get all cloudy. Kinesis is basically an event stream, and you can pipe it straight into S3, which is a storage system, and say, I'm just going to put all these events here, and then I can read them later. You can use Event Store, which is a database that is not too well known, but it's basically purpose-built for this exact reason of dealing with an event log. Or if you really want your DevOps people to hate you, use Apache Kafka. Kafka is a giant enterprise-grade super bus. Really high performance, does crazy amounts of throughput, not super user-friendly to use. But the point is, you've got options. But this kind of also brings up a question. Can we actually store all this? Because I'm asking you for an append-only list of every single thing that happened to your system. You add it to a log, and you can never erase it. You can never modify it. You can never do anything to it. Can we store that? Let's do a little math. Let's say Shooterman 64 is a huge hit. AAA game. 50 million games per month have been played. And you want to store data about every single one of them. Let's say you're storing about 5 kilobytes of data per game. Not a lot, but it's reasonable. You can fit some pretty reasonable stuff in there. I want you to think. Amazon S3. If I went to Amazon and said, I want to store 50 million game results, how much do you think that will cost you per month? 600 yen. I want to put that in perspective. These are things that are as expensive as storing 50 million game results per month. Commuting to work in a day. 50 million game results a month. Getting a beer, depending on the bar, could be more expensive. 15 million game results a month. I can watch The Witcher on Netflix, or I can store 50 million game results a month. But if you take nothing else away from this presentation, know that you can hire this man to dance to any song of your choice in its entirety in a hot dog costume for the same cost as 50 million game results per month. But you know what's more expensive than storing 50 million game results per month? Losing a customer. Because suddenly your leaderboard is out of whack, and all you can do is say, I don't know, sorry, we don't have backup. Right? Storage is cheap, is the actual point. Data loss is not. So let's get back to our original architecture. Before, we had 3 separate API calls, kind of tailor-made, that the game server was responsible for making. It goes out to the MMR, our ranking, and our KPI services. Let's look at our new world. Our new world, the game server is just saying a game ended, and it's passing it off to the log. The log stores it. more games finish, and so on, until we have our event log. Obviously, there's only 5 here, but you can imagine the scales to thousands, millions, etc. The responsibility of the game server is now literally just that. It is saying a thing happened. Also, importantly, this thing that happened is very much in the game server's domain. The game server knows exactly what a game ending looks like. It doesn't need to create these weird, tailor-made API calls out to other services that it doesn't actually really need to know about. So now, our services are going to read from the log. And the important thing here is that the arrows are reversed. Instead of the game server pointing to the MMR is pointing to the log. And this is really important. It enables a lot of really cool things. For example, when we read the log, our ranking service will start from the first event, and it will track the last thing that it saw. So it knows, okay, I read the first event, I have created what I see as our leaderboard, and I'm going to keep track of the last thing that I saw. And as it steps through, it will update its view of the world. Oh, after this game, these 2 players swapped. And so on, and so on, and so on, until it gets all caught up. This is now our current state. This is our leaderboard that we've created by stepping through each of these events one by one. And I want you to notice, game server did nothing. The game server doesn't even know what MMR is. It doesn't know that service exists. It doesn't need to know. All it did was it said, a game ended, somebody else. If anyone else is interested, you can take a look. So what happens if we crash? We had a problem before. Well, if we crashed and we couldn't reach the service, what do we do? Well, here, if we crash, let's say we're in the middle of reading and the last thing we saw was our red message. We're dead. We come back up, but now we can look at the last thing that we saw, and because we can go to the event log and say, give me everything from this point, we just pick up exactly where we left off. We go to the next, and look at that. Magic. We could have been down for 2 seconds, 2 minutes, or 2 days. The game servers were still running, players could still play, and our service is exactly where it needs to be, as if it had never been down at all. What if there's a bug? Let's say our leaderboard is slightly out of whack. Well, we bring up our version 2 of ranking. Well, this is kind of tough, right? Because we still have our current state stored in like a local database somewhere. Can't really do this. What if we just delete all of production? And that sounds crazy, but you can do that. Because when you delete all of your production data for the ranking service, I'm not saying delete your event log, don't do that. But if you delete everything about ranking, when it comes back up, it's going to look at the last thing that it saw and said, oh, I don't know where I started. I better start from the beginning. So I'll go to the first one, step through, and look, we are back where we want to be. Our leaderboards are not only correct, but they're correct, including for all the things that we may have been missing because our service was down while it was catching up. Again, game server has done nothing. Game server doesn't know anything about anything that has just happened, and it doesn't need to. So this enables some cool deployment strategies too. We can upgrade a lot more easily now. Remember before I said updates have to work? We kind of take that for granted. Well, now we have a little bit of wiggle room. What if we just bring up our ranking v2 and leave our original ranking running? We can do that because they can both read from the same log. Those events aren't being consumed. They have their own views of the world. And now our users are going to go through our little API gateway. They're going to get leaderboards, and that's pointing to our old ranking. But after ranking 2 catches up, maybe there's millions of games it has to sort through. Maybe it takes 2 days to go through. But when it's ready, we can just take a look at it, say, okay, and then swap it over. Game server has done nothing. There's been zero downtime. Keep stressing that. We can add new services. We can add our profile service that we talked about before. It can just read from the log, and it can pick out, oh, this user played on this one, this user played on this one. It creates its own view of the world of what a user needs to know about these games ending. Analytics. What are the map win rates? Just read the log and start doing some simple math. Cheat detection. Machine learning magic. We'll pretend that works. But the cool thing is, if I came to you and said, I want to do a user profile service where I want every user to see what maps they've played over the past few months the most, because that sounds really cool, right? And you would have to go normally like, oh yeah, that does sound great. I guess we can start it now, and then a couple of months later, people can see their history. Well, if we have the whole history, we can generate all that data in the background, and when it's ready, give it to users. And it's as if it's always been there. It's really cool. So I've given a couple of benefits here. Our game server is decoupled. Adding services, removing services, modifying services, service downtime, all of that doesn't matter. Awesome. We have trivial downtime recovery. If our service is down for 5 minutes, I mean, yeah, that sucks, but we know that when it comes back up, the data will be correct, and people that are accessing it will get what they want. We've got some new deployment options. Because we don't need a single version of this service running, we can have multiple versions side by side. We can put up some experimental things and see how they work. We can canary things out much more easily. We can put in upgrades, make sure they work, and have confidence in them when we actually flip the switch. New services have history. Again, user profile comes up. I can read back and generate all the data that I want, and people are suddenly seeing all this cool new stuff, like, oh yeah, I played on this map so much last month, haha. And you can actually debug with production data now. I can just copy a good chunk of my event log and run it through stuff that I'm working on locally as much as I want. And I know that when it hits production, same data. So I also want to say one more thing. You've actually already used this a lot. This is a concept, not a technology. Remember I said don't put stuff in text files? That's actually what Git does. Git is literally the system. Git is a series of events, changes, commits, that happen to add up to exactly a state of working code that you're seeing now. Same thing. And it's just text files. Game systems. StarCraft, I think, is the best example. A StarCraft game state is just running the same StarCraft engine function over the events of input from both players, all the way through. So this is, if you think about it, your current state is just a left fold of all previous events. And what I mean by that, because left fold is functional wizardry, is that your current state is really just the same function applied over incoming events over and over and over and over. So if you keep those events, you suddenly can bring your control over your state to a whole new level. Thank you. Any questions?
What happens if your production data gets corrupted?
Yes, so there is kind of the underlying trade-off of, instead of, oh, my leaderboard data got corrupted, but everything else is fine, it's now, oh, my event log got corrupted, we're all on fire and jump out a window. I will say that having a single point of failure that is built to be robust, is replicated out, is backed up, and so on, is better than having 20 points of failure that have to be replicated and backed up and thoroughly tested and so on. It's the systems that are built to be an event log properly, like Apache Kafka, Event Store, Kinesis S3, and all that. You absolutely need to make those as bulletproof as possible, but that is what the open source community has been doing for years, to do exactly that. That is the purpose of those systems. But it is absolutely a thing you need to be aware of.
Let's say, for instance, you change the precision of the timestamp at some point. And so what would you do? You would store one more value in your event, which is the new timestamp, or you would change all the readers to make it fit the new format. And if it's something a bit big, for instance.
Yeah, so Protobuf actually has a way of dealing with this, where they say you can't make breaking changes. If you are making a breaking change, you make a new schema. So it would become a new event entirely. So you would need to update your readers in order to deal with that. You can also add fields to Protobuf. I'm using Protobuf as an example, but you don't need to use Protobuf. But you can add a field to a proto, so like timestamp super precise as the name, and then put in the time there, and then either still keep the old one or deprecate it out. But you will need to. It will be a case where you have different kinds of data. So the older events will have that less precise timestamp, and the newer events will have a more precise timestamp, and you will need to be able to handle that. But if you're building the code to take advantage of this, it's not usually a huge deal.
Data retention, like of your logs, like typically how long do you keep your
Forever.
data? Like, forever?
Forever. Like it's so. I'll bring up one point. Snapshots are a really powerful tool here, and by what I mean by that is that you will keep history forever, and you will put it in like super glacial tape storage. Like get some USBs, run it through zip 50 times, and hope that somehow makes it smaller. And you'll likely never need to touch it, because what you'll usually do is your services will take snapshots, maybe a daily snapshot. Think of it like a backup kind of for themselves, where they will say, for example, for leaderboards, the last thing I saw was the red message, and here's what my state looked like when I saw that red message. And it will save that hard somewhere that I can reload later and pick back up. But yeah, you actually do want to just store everything forever. And that sounds crazy, but it's actually pretty cheap for the scale that you're going to be working at.
How does this work with like P2P kind of games? Like, can you make it work with that?
In what
Or-
sense?
I'm not sure. Like, it's like all very centralized along the log, right?
Mhm.
And with like P2P, like maybe one of the clients is off and one is not. Like, and then you resolve it with the event log, or
So that I would say if you're dealing with like StarCraft, using that as an example, and this is a bit different from the separated out microservices architecture, but as an idea, StarCraft just kind of they both have to agree on their events being the same,
right?
and they both create this deterministic view of the world.
Yeah.
Beyond that, I don't know if it's a super helpful
Okay.
thing to deal with there.
All right. Just curious.
So generally, when you're going to finish a game, the server doesn't have to care necessarily about what's going to get recorded, given a game or a gamification event. But your game client will need to get some information. So, for instance, say you have achievements,
Mhm.
right? You might actually say, well, the game's over, and then like your achievement microservice gets the event, computes it against the existing player data, and then says, okay, this achievement has been reached, right? How is the client going to wait for a server-side event to be pushed to it? How's that going to work? Basically, you're going to say you're going to basically just accumulate all the events, and then it's going to be like you have no achievement, your ranking has not changed, and so on and so forth, and just collect this on the client, or is there a better way to do that?
I would say off the top of my head, I would still have the server kind of be authoritative in that, in the sense that it does say like the game ended, and then the achievement service or the ranking service, the leaderboard service, will be updating their data. They see some trigger for that user, and they push some event to that, or the client then asks that service a couple of seconds later, and so on. The one catch I would say when it comes to client side is that if you trust the client to put in events, you will get garbage events from somebody being cute or having some weird device issues. And because you need to keep these forever, you can't just say, "Oh, I'm going to delete these." Like, well, they happened.
So with the case of waiting for a few seconds before, like doing a client-side read, for instance, to directly to the API,
Mm.
you don't know how much of a backlog you have, right?
Correct.
So you might assume that 2 seconds is going to be enough, but given like your game gets like a huge spike, and now things stay that should be 99.9999% of the time they're processed within 2 seconds. Now they take 4 seconds.
Mhm.
Right? So now your client is going to start to not show things. Right?
So I will say that working with Apache Kafka, as an example. When I was working on the data pipeline at Blizzard, many things broke, many things fell behind. Kafka was never the thing that slowed us down. It was always our individual services themselves. So if you've built a service that can handle that kind of load, I genuinely do not think it will make any difference whether it's using something like this or it's using something where the client is trying to feed it information going back and forth.
Any other question?
Yeah, so this whole thing has been about online multiplayer, right? For your game, is it Shooter Guy 64?
Shooter Man 64.
So if my memory is correct, I don't think that Shooter 64 had online. So how do you plan to?
No, see, this is going to be like the next gen emulator.
Oh, okay.
Yeah. No, it's super unreleased tech for Nintendo 64.
Thank you.
No. I just broke 30 NDAs. Hope you're happy.
All right, I think we're going. Well, thank you very much.